Hello everyone. In video number 128, I believe it was, I had introduced this little NIU function generator to you guys, and I already knowing the problems that these have done in the past by doing YouTube searches in the last year. There's a problem with this thing that you need to be aware of. Now, there's already a lot of reviews on the internet about it, but I want to go ahead and share with you the dangers of this piece of equipment. Now, when I first tested this, I said, well, it's not too bad, but I want to go ahead and show you some of the problems that you can encounter with this thing, not just because you can damage the piece of equipment that you're testing with it, but also I'm not saying that it can kill you, but it can give you a good shock or a jolt if you're not careful, if you got wet fingers or something. So let's take a look at this and see this problem and how can we eliminate it. Looking here at the back of the unit, you can see where the AC power cord plugs in, and as you can see, it's only a 2-wire cord. It's 2 prongs, and it can go in either way, which means the hot could be on either side and neutral could be on either side. Also, with the plug, it's not polarized, so it can go into the socket either way. Now, this unit uses just a switch mode power supply, and I think it outputs a couple of 5-volt leads, a positive 12-volt and a negative 12-volt. But I want to show you something that's not too good when you're using this thing. Okay, I have the unit plugged into the AC mains, and the unit is off, and all I'm going to use is just a scope probe. And what I'm going to do is just take this scope probe and I'm going to touch one of the BNC connectors, doesn't matter which one it is, and we're going to look at the signal on the oscilloscope. Okay, now this oscilloscope is one that I've added to a mail time video, and we'll get to that later on in the week, I hope. But this is a good scope to show you what a problem is. And it's just a little 20 megahertz oscilloscope, so it doesn't take a lot of us, bandwidth to show this problem. But all I'm going to do is just touch the probe to the BNC connector. And you can see that on the screen now. Now remember, the unit is still powered off, and what I'm going to do is just flip the unit on and let you look at the waveform. I'm going to just hit 10 times on the probe, see if I can't bring it down, and you can see it's pretty big signal there. So here's the problem I want to show you. Let me get this voltmeter, try to get the glare off of it. I'm on AC voltage. I'm going to turn the unit back off. I'm going to go down here to a ground lug on the mains, and we're going to touch the BNC connector. And as you can see, we have 3.545 volts on this unit. Then we'll turn it on, and then we'll touch it. 45 volts. All I'm going to do is pull out the mains cable. I'm going to turn it around, plug it back in, and we'll test one more time. And it's still at 45 44.7 volts, so it didn't make a lot of difference. But the thing is, there's still voltage on the output jacks or the input jack for the counter, and it doesn't matter which one you go to, there's voltage there. So why is this a problem? I've already watched a video where a guy tested the leakage on it, and it was about 100 microamps, which is still in the safe range. And you know, you probably can get a tingle out of it if you go against earth, ground, and these BNC connectors. You'll probably get a tingle, a little bite. But you know, there's always a possibility of something in the power supply shorting out and you get a nasty bite. And another thing is, you know, 100 microvolts or 100 microamps going into MOSFETs or, you know, FETs, JFETs or whatever, most likely it's going to zap them and wipe them out, and your equipment in the test is going to fail even worse. And the problem that's causing this is the switch mode power supply that they're using. Now, after watching several videos, it seems like a lot of people are getting different readings. I've seen some as low as 20 volts and some as high as mains voltage. Like, you know, here in the US we use 120 volts, and some people are actually measuring 120 volts from the connector to ground. This is not good, and what I want to do is just look at a few ways to eliminate this, to correct this problem. So I'm going to go ahead and open up the unit, and remember, you know, it says mains voltage. If you're following along, you know, you're doing so at your own risk. Be careful. You know, there's mains voltage is very dangerous. So remove the power cord, and I'll go ahead and get these screws out, and we'll get the top opened up. So we're taking a look inside the unit, and you see this little switch mode power supply. You got your AC inputs coming in. It's your switch wire. And here we'll have our voltage source out. Like I say, there's 2 5 volts, 2 grounds, plus and minus 12 volts DC. Now, probably the best way to fix this is to rip the switch mode power supply out and just go ahead and build a linear supply to go back in, you know, the unit. It's, you know, it's a lot of space here, so you got enough room to design a power supply to go in here. But we're going to try a couple of other things and see, can't we eliminate this issue. So if you notice here in the back, you can see that these connectors have 2 wires, you know, your center wire and your ground. And what I want to do is verify that there is ground going from these units to the front panels. And we just want to do that by continuity test. Yep. Let's verify the other one too. Yes, so we do have continuity from this ground to the front panel connectors. So what I'm going to do now, I'm going to take a lead and I'm going to clip onto this ground lug, and I'm going to bring it down to a earth pin here on my mains outlet. Plug the unit back in. Again, be careful playing with mains voltages. And we'll plug it back into the wall outlet. Go back to AC voltage. Let me get this so you can see it a little better. Okay, I think I have everything in the shot now. I'm going back down here to my ground. And we have no voltage. Turn the unit off. Give it a test. And there's no voltage. So what we're going to do now is just to verify on the scope. Have the unit off. We'll touch the BNC. Turn the unit back on. And there's nothing coming out. Okay, so we have the array gauge hooked to it, and we want to verify that we haven't affected the output of the unit by grounding. And we have a signal coming out. And there's our signal on the oscilloscope, so all that looks real good now. Alright, we're back on the analog scope, and what I want to do is just look at the signal and remove this ground wire just to see if it affects anything, just to be sure. Alright, so there's our signal on the scope. I'll remove the earth ground, and you see no change in the amplitude or the signal on the scope at all. And we'll put it back on so it's still good and stable. So I'll remove the power supply out of the unit so you can get a good look at it. And we're sure that what's causing the problem is safety caps in this thing. And I'm feel the reason why everyone gets a different voltage is depending on the components that are used in this switch mode power supply. And if you use a better quality, you'll get less. And probably some cheaper ones are going to allow more leakage current to go through. Now you got to remember the first thing, this is a cheap piece of test equipment, and the reason why it's cheap is that they're going to use cheap parts. You can look at the capacitors, and they say it's 105 degree C rated, which I doubt it very seriously, and Young Lee capacitor. So it is what it is. It's cheap. And if we look at the back side of it, you can see the construction, and you can see they got a pretty good wide gap in between the main sides and the DC side. So they didn't do too bad, and even the soldering looks fairly good. It's not nothing to write home about, but it's not too bad. Even between the AC, it's pretty good gap, but here, it's kind of close here, so I don't think you have to worry about too much creepage voltage across it, but still, like I said, it is what it is. So let's see if we can get the voltage off the outputs without blowing the board up. Okay, so I plugged all the connections back into the board, and Down here on the output connector, I want to verify that this ground is attached to the ground of the BNCs, and I have the multimeter connected to the ground side of the BNC, and as we can see, it is grounded. So along with the switch mode power supply, the way it's designed, and these floating connectors, you know, the ground, it's floating above ground. So I think what we're going to do is just go ahead and rip out this 2-pole power connector and go ahead and put in a power connector that has a ground on it, and then we'll tie these grounds from all of the connectors and to the board to an earth ground here to eliminate the problem. Alright, so I moved the AC power cord. Now, I did look online. You can get these in 3-prong, and it's got another ground prong is right up here, you know. We could order that and pop that in there, but you know, then we're spending more money. Thing is, you know, we're trying to keep things pretty cheap. So I got this mains power plug out of a old computer power supply, and we're probably going to try to put this in there. Now looking at this, you know, if I try to put it in here this away, you know, it may interfere with our lip that goes into the chassis. And then we got, you know, this standoff right here that may be in the way also. So I may end up putting it in here this way and then filling in the hole on one side of it. I have to look at it and see. We'll get a peek at it and see what we can do. Okay, so I was able to fit the mains connector in horizontally the way it should be in, and we do have a little gap there on the edge. There won't be no problem, just an extra air hole. And I fitted the back panel into the slots here, and no problem clearing the mounting stud. I did cut the hole this way as far as I could so that the mounting flange wouldn't protrude over on this side, so that shouldn't be a problem. Then we can get this thing wired up and see how it works. Okay, our plug is in. We got our mains wiring on. Went ahead and heat shrink the terminal so it'll be a little safer, so you can't accidentally touch it. And the plans are to run a ground wire from here to these BNCs. Now I'm not going to trust the internal wiring going to the front panel to carry the ground. We'll go ahead and run a separate ground up to the front panel and to the power supply board. Alright, let's take a look at what's going on here. I've come up here to the front panel and I've soldered a wire to both of the output jacks. This is all ground plane here, and it's connected also to the counter jack, but I went ahead and reinforced it on one side with an extra strip of wire, and we have the ground wire coming off here. Also mounted a terminal lug right here on this extra standoff. I took a power supply board. I've come off on this ground plane with a wire. As you can see, I have a ICE connector here with the ground that's coming over to a switch, and then it comes down to this pigtail, and also both of these are grounded together, and a wire coming down to this pigtail also. But we'll talk about the idea of that switch here in just a moment. What I'm going to do now is go ahead and get all this together and get all these wires on this ground lug here, and then we'll come right back. Okay, everything's all wired in. Might come back and take some hot glue and just tack these wire down to keep them from flapping around. Now this switch in the back, I didn't want to connect everything to the switch, and that's why I put the ground lug down here in the bottom, so everything will connect to that. It comes up to the switch and just simply goes over. And what I did was just put this switch in here to, if you put it on this side, everything is now earth grounded. If for some reason I need to go in and float the inputs, I can. But remember, when you float the inputs, there is low current AC voltage on the output connectors, and by putting it on ground, that should take care of it. So let's give it a test and see how it does. Okay, we'll go ahead and plug the mains into the back of the unit, plug it in. I'm going to go ahead and leave it in the ground position. I have the AC power turned off at the moment, because you're getting to see it as I see it, and see if this modification helps at all, or if the whole thing just blows up. So I figured, you know, it's going to blow up, why not show it? Okay, AC volt scale. I have one side grounded to the neutral. I'll turn the mains on going to the unit, and we'll check. Let's see if y'all can see this voltmeter, if there's a glare on it or not. I think y'all can see it there. And we have nothing on the outputs. Check the ground on the USB board. Nothing there. Here comes the moment of truth. Unit powers up. Again, still in the ground position. And we have no AC voltage on anything. So I'll come here and I'll go to float, and you can see there's our 44.0 volts back to ground, and it's all gone. Now, as I said, the current on this is very, very low. Probably, you know, 100 microvolts at most. That is enough to destroy MOSFETs, FETs, or so forth. And it also will add noise onto your signal. This should eliminate a lot of that noise. So there shouldn't be no problem there. The only thing I can see that could happen now is safety cap short, and that's going to throw AC to ground, but it's going to blow the fuse. There is a fuse inside this unit, right down here beside this little transformer. So we should be pretty good protected. Now I'll have to go back and, you know, just do some testing to see what I come up with, but I feel like this is just a quick, simple fix to eliminate that voltage. You know, at least takes the risk of getting shocked out of the equation, and it should protect whatever you're working on. Again, you know, I think the safest, best way to do it is to rip out the switch mode power supply and build a good filtered linear supply to go in there, and we may do that later on, but I'm going to try it like this for a while. You know, also switch mode power supplies can create noise, and if you're in here generating a signal and there's noise coming from the switch mode power supply, that's going to show up in your readings also. But for right now, we'll just check that and see what happens. Okay, we have the generator back on. Now a 10 kilohertz sine wave at an amplitude of 2 volts peak to peak. And let's have a look at the scopes. You see here on the Hitachi, we have it set for 1 volt peak to peak. And we're covering 2 graticles, so that's 2 volts. And over here on the Rigol, now I'm not as worried as much now as connecting it to the Rigol, since we have the AC off the output jacks. I mean, one thing you don't want to do is blow up your test equipment, so hopefully this little modification will keep from doing that. And we see we have a 10 kilohertz, just about bang on from the what the unit is set to. Anyway, like I said, I'll do some more testing on this here in the future, and make sure everything is up to par. I'll also look at designing the new power supply board to go in it. But I think for right now, this modification will definitely help. I mean, I think, you know, the worst that can happen is safety cap was to short and blow the fuse, but we should be pretty much protected the way I see it. So anyway, I'd like to hear your comments down below. Click the show more tab if you want to get contact information. Follow my link to Patreon to support if you like to, and we'll see you in a future video.